Okay, folks. Here is our third section of videos for um, 2.1, and for this one, we're going to do coterminal angles. It's a good thing I'm not an English major. Coterminal angles. Okay, so um, basically, here's what a coterminal angle is. All right, if you remember, an angle in standard position looks like this. An angle in standard position is an angle that has its initial side on the x-axis, initial side, and the terminal angle can be somewhere else in here. It doesn't have to be in this particular section. It can be anywhere else, okay? But this angle would be considered in standard form. Now, coterminal angles have the same terminal side. If you were to put both of these angles in standard position, they would have their terminal angles would fall at the exact same position. So, for instance, if we look at two angles, one of them is going to be 60 degrees, and one of them is going to be 420 degrees. Alright, so with the initial side on the x-axis, 60-degree angle would be somewhere right in here. Okay, that would be our 60-degree angle in standard position. Basically what it means is when you see a 420-degree angle, 420 degrees still has the initial side here, but it starts and it's going to go all the way around to 360 degrees, and then up to the 60-degree angle. This would be 420 degrees. So 360 plus the 60. So if you notice, their terminal sides here are in the exact same position. So we would say these two angles are coterminal. Coterminal. Okay, so now here's a hint. Okay, for degree measures, for degree measure angles, there going to always be some integer multiple, I should say. Some integer multiple of 360 degrees. Radian measure will be some integer multiple of 2 pi, okay, of 2 pi. So if you notice, 60 degrees and 420 are an integer multiple of 360, because see, we could say 60 minus 420, and that's going to give you negative 360 degrees, which is negative 1 times 360. So this is an integer multiple of 360, so they're coterminal. Okay? Well, you can do the same thing for radian measure, so let's show that. So the directions would say, which of the following pairs are coterminal? Okay, so let's just say angle alpha is a negative 135 degrees, and angle beta is equals 225 degrees. Get used to all these Greek symbols, okay? So, how do we tell if they're coterminal? Well, first of all, let's subtract alpha minus beta. So that's going to be negative 135 minus 225, which is going to give us a Negative 360, which is we just saw, is negative 1 times 360. So yes, that is an integer multiple of 360. So yes, they are coterminal. They are coterminal. Okay? Very easy to pick out like that. Let's look at another one. Let's let alpha be 120 degrees, and let's let beta this time be negative 420 degrees. Okay, so again, alpha minus beta, so 120 minus a negative 420. Okay, and so that's going to give us 540. 540 degrees. Now notice, this is not a multiple of 360. This is not a multiple of 360. 540 is not. 360, and then it would be 720, and then 1080, so on. Okay, so 540 is not a multiple. If you were to actually try to write it as a multiple, it would be 1.5 times 360. Now, the definition says this number here has to be an integer for them to be coterminal. Has to be an integer for them to be coterminal. So this would be a no. This would be a no. They are not coterminal. All right, now, the degree ones, they're the easy ones because that's how our mind thinks. My mind thinks in degrees. Your mind thinks in degrees. So let's look at a radian measure. Let's let alpha this time equal negative pi over 3. And let's let beta equal 2 pi over 3. Okay? Same thing again, alpha minus beta. So negative pi over 3 minus negative pi over 3 minus 2 pi over 3. Well, we already have a common denominator, so that's going to be negative 3 pi over 3, which is negative pi. Well, that is not a multiple of 360, or in this case, remember what I said, it's either got to be a multiple of 360 or 2 pi. That's not a multiple of 2 pi. Okay, that would be a negative 0.5 of 2 pi if you were trying to write it out. If you were trying to write this out, this would be this. Okay, so notice that is not an integer. So this is not a multiple of 2 pi. So these are not coterminal. Not coterminal. Okay? Hopefully you're getting this. It's got to be a multiple of 2 pi. So 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, so on, like that. Okay? Hopefully that makes sense. All right, so let's look at another one. Let's let alpha equal pi over 3 and beta to equal 7 pi over 3. So pi over 3 minus 7 pi over 3 equals a negative 6 pi over 3, which is a negative 2 pi. Now this is a multiple of 2 pi. Now it's easy to see because it's negative 2 pi, but this is actually negative 1 times 2 pi. Negative 1 being an integer, so yes, these are coterminal. These are coterminal. Okay, so always try, if you're having doubts, try to write it in the form of 2 pi. Okay, one way you can do this is you can take the answer there and divide it by 2 pi. Negative 2 pi divided by 2 pi. If it comes out to an integer, it is it's a multiple. You can do the same thing with the degrees. Divide by 360. It should come out to be a multiple. Because see, if you look back, well, it didn't save it, but if we look back, we had negative 360, negative 360 for one of these. If we divide that by 360, that's negative 1, so that's an integer. So these are multiples. But when you took 540 and divided by 360, you got 1.5. That may be easier for you to recognize it like that. Instead of trying to figure out what multiplies to give you the multiple, you may want to divide by the multiple. And if this number here comes out to be an integer, well, you're good to go. That's a multiple. If you can't tell offhand. Hopefully you can tell right offhand. But if you can't, divide it or try to write it out in terms of if negative 360, try to write it out like this. Well, that's an integer, so it's a multiple. Or you can divide it like we did here. Either way will work for these particular problems. Okay? So this would be coterminal angles. So we have probably, hopefully, one more video and we'll be done with section 2.1. Let me know if you have any questions.